Good afternoon. Thank you for hanging in there. We've lost a few people on the tea break, I guess. Um, but very nice to be here, and thank you for your attention. What I'd like to talk to you about is post-harvest technology. We've heard a lot about pre-harvest and all the effort and the beautiful innovation that goes into the produce before it's harvested. But can you imagine roughly how much percent of that produce is actually eaten? Who would say 90%, 80%, 70%, 70%? I have some voters. 60%, 50%. Oh, oh, you are a bit dramatist. No, actually, it's 2/3 that we eat, and 1/3 is getting thrown away. Well, that's where we come in. We would like to have that beautiful product that has had so much effort put into it at an excellent quality on your plate, not only after harvest, and then actually be eaten. And that's why we have post-harvest technology, and we are working for innovation to improve that. This is our facilities in Wageningen, food and bio-based research. You've met my colleague Frans, who is with Wageningen University and research. I am in one of the research institutes there, and we work on everything after harvest and what we can do to have excellent quality food on your plate. I'm the manager of post-harvest technology, a group of engineers, physiologists, working on that. And we are actually in the middle of the innovation funnel. But now, what is an innovation funnel, you might ask yourselves. We start with fundamental research. That is our colleagues at the university. They are curiosity-driven, and they make up new plans through knowledge push. They will come up to you and say, I've invented this or that, will you use it? But that's where we come in. There's also a question from the industry, the market pull. And that's where we focus on how to apply that knowledge so that it actually has impact. So we are a contract research organization, Wageningen Food and Bio-based Research, working on applied research, demonstration, pilots, and actually getting things done together with you in industry, implementing so that it all comes down to business and science for impact. So we focus on practical results. We base them on science. We also research ourselves, but we find it very important that things are also lab and field tested and real life measured and then used in practice. We have 16 different expertises post-harvest, and what my group focuses on is post-harvest technology, and that is for the fresh chain. We do engineering physiology and especially also computer vision as a specialty. But my colleague has told you a little bit about that, so I will focus mainly on the top two. But if you're interested, we also have process technology, supply chain management, food informatics, and consumer science, so that the whole fresh chain up to if people actually like to eat your Brussels sprouts is being covered. So we try to improve innovation in the fresh food supply chain. And what we see is that retail is for us in Europe, and I guess also here in Australia, the major outlet for fresh food, so that it has a very high buying power, and their rigid specs are very important as to what we do. That goes also for the USA. 90% of fresh food is being bought in the supermarkets. Very different in Egypt or Vietnam. These numbers are much lower. But then they are also tending towards more supermarkets driven sales. And that means that also they and we have to have this high quality. Well, actually, do we have to have this high quality? You might be mistaken. What they actually mean is that you have consistent quality. It shouldn't be top high just one of the months in the year. It should be the same all around. And that is sometimes a challenge because we source globally. And you would go from South Africa to Chile to Peru to buy your product as a retailer. And then you have late season avocados being bought from one of the countries, and a few weeks later the client returns and thinks, I will have that same avocado, but it will be in early season from a different country. Which makes a lot of difference, and a lot of times he or she will be disappointed to not get what they're expected. And that's why the retail is so rigid about their specs, that the quality should be consistent, so that they will buy again and again, and that we will sell eventually more fresh produce, which is good, because it's good for people and they are getting more healthy through eating more fresh produce. So that's where we go with the retail, that we should have that consistent quality. And if we've achieved that, then we can upgrade the level to a higher standard over the whole year. Well, that means that we have to deal with the seasonal shift, and of course also with the food safety and the maximum residue levels, as you all know. This is what we like to show. We do not have these beautiful pictures, we have these a little bit nasty pictures. Because that is the challenge. As we source globally, the storage and transport time increases, and the shelf life guarantees are necessary. But then you run into botrytis, or uneven ripening, as you see here, or shriveling on your bell peppers, or these weak necks. And a lot of waste comes up. For instance, if the vines on the tomatoes have mold on them, as you see below, or these really beautiful bananas, which actually have these sugar spots and are really sweet. They are not being bought in the Netherlands. Are they being bought here, if they look like this? Would you buy this? If you can raise your hand, would you buy this banana? Yeah? Oh, you're the experts. Well, most people in Holland will not buy it. So it's being thrown away. Well, these are actually the best. So I buy them, I get them much cheaper. And that's what we Dutch like, of course. But then you also have these avocados, which is worse. They look nice, and then you cut them open and they look like this. That's what we are working on. Some more. Scald on apples. Actually also not bad for you, but people won't buy them. Penicillium, that's worse. Also not being bought. And this internal browning, examples of apples and cabbage, where you have that as well. All different types of post-harvest problems that technology can help to solve. Or at least not solve completely. As we say, the post-harvest chain is not a hospital. We are not improving quality, but at least we can make sure that the quality is sustained as much as possible. And not being deteriorated, as you see here in this picture, the bananas with underpeel discoloration, because they are stored on a too low temperature. Or one of them in the box is has some rot on it, and then after transport, being transported in a reefer container in this instance, the whole box is being ripened and gets thrown away. So this is the 35% on average that we are throwing away, both in developing as in developed countries, I must say. In our developing countries, the distribution is 21% is thrown away or wasted. But then the consumer is a bit more effective. It's only 12%. So actually, they together have 34% thrown away. 33, and we in the developed countries have 1% more, because we as consumers throw out a lot more. up to recently, there were very little data sets available. We've done a project in the EU where we started out to actually define what food loss is, so that we can measure it, so that we can start to solve it. And now the European Union has taken on this set of defining factors of what food loss is, and the United Nations has taken it over, so now we can start to actually measure it all over the world, and then solve this major issue of 1/3 of the produce being thrown away. We also discovered what are the major factors that cause this waste. And that's where we saw again how important it is to close the cold chain. You see here the number of references in literature, because there is a lot of literature on food waste, against the cost category, and you see that the cold chains and closing the cold chain is the most important factor in reducing food waste. But also improving storage facilities, product handling, and packaging. Those are the 4 major factors, and we at Wageningen Food and Bio-Based Research are exactly working on those topics. So we'll be around for a while longer. So what do we do? What kind of solutions do we work on? That is monitoring the temperature and the relative humidity, for instance, in the cold chain, and then improving it for quality control. Also defining markers for quality, and modeling the quality throughout the chain. And making new storage protocols and facilities, such as controlled atmosphere, but also dynamic controlled atmosphere, so that we change the settings, having the lowest possible oxygen for that batch of that season, measuring it through volatiles, for instance, working on mixed load and ultra low oxygen. Then transport, having protocols for perishable handling. As you saw, closing the cold chain is really important, and then how to do it for that specific product from that farm to their end user. What kind of chemicals or biochemicals to use, what kind of packaging, etc. Then pre-cooling systems, designing cooling systems, and protective packaging, and ripening control. What we would really like is to say we want to have that ripe mango on Tuesday, and it will be ripe exactly then, and not the Wednesday after when your visitors have gone. So that will be ready to eat on demand. And finally, what we use, for instance, for that is sorting and robotics, and there's where computer vision and imaging comes in. Some pictures from our facilities. You see from small scale to very large scale laboratory facilities where we have dynamic temperature control. We can simulate the whole chain, and also the shelf life, so that we can measure exactly what's happening in the lab, and then next we do pilots real life. And you see on the bottom a picture of our reefer and truck test room, full scale, so that we can also have a full truckload, and opening a new one this fall, which is able to have temperatures of -20 to +40, so that from the polar to the Sahara circumstances we can simulate that. That is a picture of the extension of our laboratories. We're opening October 6th. In case you're around, very welcome to come and see this upgrade of our facilities. And if you can't come to us, then we are very happy to come to you. Because we think it's very important to strengthen this innovation and knowledge base, so that we do a lot of on-site courses. Here you see a picture of a course that we gave in China with people from industry, and having also practical lessons, seeing what's happening with your produce. And to sustain this, actually, what we're working towards is having these FICs, or post-harvest innovation centers, throughout the world. There's not so many practical research facilities such as ours up to now. Mostly it's either universities or companies working on it, and we would like to close the gap with these post-harvest innovation centers. So that we do research and pilots with local products. We now have to fly them in. Of course, there is some time lapse, and it's even better to do it on location. So we can improve the skills of the people working regionally, and it will also be a showroom for novel technologies. And this is an example from what we did in India. Due to time, I will skip that. And what we do together with companies is make data available. This is a new type of looking at the set points for your produce. We have this data around of a set point for tomato on the vine. UC Davis has done a lot of work on it, and they have it online. And so there are many of these type of protocols that usually sets this is the set point, or maybe a range. But we have to go to this, saying, depending on the distribution days, these are the optimal and suboptimal temperatures, because you have mixed loads as well. And we would like to do this not only for tomato on the vine, but for a very large range of products. We are now towards 20 or so, so that it's for all your produce easy to say, where am I going, what am I transporting, and then what is the optimal temperature that I could use. This is again on how you make such a post-harvest innovation center. We could give advice for the design of such a center, the hardware and the software. And of course you need orgware, make the right research teams available and throw up the expertise. And then connecting public and private through partnerships and solve the IP such as that we have done in Wageningen. So we could set that up also locally, but it takes some time, of course, to build such an innovation center. So we have now have a mobile lab available. At least it's going to be ready in June, and from the summer you can lease it. And it's a mobile lab, about a 40-foot container, all filled with equipment, and we can train a researcher or a new researcher to use that on location and to be able to do post-harvest research on site. This is a course that you might be interested in, course Post-Harvest Technology, in October, a full week specifically for people from industry with practical applications. Then we have lost harvest and wasted food, and we could also come to you on the spot. And what we explain is how to use this smart chain concept, what our projects are there, where we go from initial quality, measuring that through chain conditions, to quality development, and what happens in that post-harvest chain, so that in the end we will know the quality of your produce and what to do at each step on each step of the way. Measuring, for instance, through with a chip, and having a model so that we will go from first in, first out to first expired, first out. And so that you will know on Tuesday I will have that really nice mango. And then on Thursday I will have that great avocado. And I'll throw it in the bin. Thank you for your attention.